Hey there guys, welcome to the video. My name is Pushpinder Gill, and in this video we're going to be talking about histograms. So this is a statistics video in which we're talking about how can you represent data using histograms, right? Now histograms give you a good picture of how data is distributed. It actually enables you to see kind of a general shape of the data, how the data is spread. So it actually gives you a view of how the data is spread. It's actually very critical to understand how to form histograms using data. Now let's go ahead and get started, guys. Right? So I have an example here. Before I actually use this example, I would actually like to point out some important features of a histogram. So histogram is something which actually looks like this. So on the left hand side you have your frequency distribution, which I'm going to be talking about that in the next few minutes. That is frequency density. And on the x-axis you have your x values, right? And you have your histogram to be like this, right? So there are few properties that are associated with the histogram. The first property is that there are no gaps between the bars. So there are no gaps between the bars. As you can see that there are no gaps between the bars. That's one property of histograms. The second property is that the area of each bar is directly proportional to frequency of the x value. That is directly proportional to the frequency of the x value. We're going to be knowing a lot more about this. So let's go ahead and get started. So let's say I'm going to start with an example, right? So let's suppose we have this example. We have these x values and we have these frequency values. Now what you're going to do now is you're going to calculate the class width, right? So what is the class width actually? So the class width is the difference between the lowest class interval and the lower class interval and the upper class interval. Well, the lower class interval here is actually equal to 20. The lower class interval over here it's actually equal to 25, and the upper class interval here is 30, which means the class width is 5. Here the class width is again 5, and here the class width is again 5, right? If you do not know what class width is, then I'll recommend you to go ahead and watch our first video on statistics, that is the introduction to group data. But you should know that it's just the difference between the upper class value and the lower class value. And over here it's 10, and over here it's 30, right? So this is what we call as the class width. So this is nothing but known as the class width. Now moving forward, what you do now is you have to calculate the frequency density. I'll denote this by D, which is known as the frequency density. Now frequency density is actually given as the frequency of that value divided by the class width, right? So frequency density is equal to frequency of the value divided by the class width. So this frequency density over here is going to be 55 divided by 5, which is actually equal to 11. This is equal to 55 divided by 5. So that is equal to the value of F divided by W. Similarly, you're going to have 39 divided by 5, which is going to be like 7.8. Then I'm going to have 68 divided by 5, which is going to be 13.6. I'm going to have 32 divided by 10, which will be 3.2. And 6 divided by 30, which is going to be 0.2. Now is my time to go ahead and create the histogram, right? So what I'm going to do now is, using this table, I'm going to create the histogram. So if I were to create the histogram, I'll use that in a different color. I'll actually on the y-axis, I'm going to have the frequency distribution, which is this, and on the x-axis, I'm going to have the x values, which is this, right? So that is what your your histogram is going to look like. Now another thing important over here, that we have to actually label everything correct. So frequency distribution goes from 0.2 all the way to like 11. So I'm going to mark this start from 0, start from 2, let's say 4, let's say 6, 8, 10, and 12, right? So that is going to be my frequency distribution, and this is gonna start from, so I'm actually gonna draw it like this. I'm gonna actually start from 25, so 25 till 30, and then we have 35, and then we have 40, we have 45, 50, 55, 60, and we have to go all the way till 80 now. So let's do it like this and write 80 here, right? So that represents that I'm actually counting all the way from 60 to 80 because I don't have the space to do that. Okay, now what we're going to do is we're going to draw the histogram. So 25 to 30 has a density of 11. So 25 to 30 has a density of 11. So what is going to happen is this is going to go all the way. So let me just extend this till 14, right? So 11 is going to be right here. So this is what 11 is going to be. So 25 to 30 is actually 11. And then we have 30 to 35 as 7.8. So we have 30 to 35 as 7.8. So 7.8 is actually going to be like this. So this is how we create the histogram. So 35 to 40 we have 13.6. So 35 to 40 we have 13.6, which actually looks like this. And then we have 35 to 40 is 13.6. That's what we did. 40 to 50 is actually equal to 3.2. So 40 to 50 is actually equal to 3.2, which is actually going to be right here, and it's going to go all the way till 50. And then we have 50 to 80 at 0.2. So 50 to 80 as 0.2. So that is how 50 to 80 is going to be like, right? Now what is this distance over here? Just gonna point to that distance. What is this distance over here? This distance over here is actually your x value, isn't it? That is 25 to 30, which actually represents your class width. So this represents your class width. And what does this represent? This represents your frequency. So what is it? Sorry, this represents your class density, right? So your frequency density. So this represents your D and this represents your W. And you already know from this expression that D is actually equal to F over W, and F is actually equal to D times W, right? So F is equal to D times W, which is equal to the width of this rectangle, which is equal to the width of this rectangle into the length of this rectangle, right? So into the length of this rectangle. As you can see there, that this is actually your frequency density. So this is into the length of your rectangle. That means your frequency density, your frequency is given as the area of each bar. So area of the bar would represent the frequency of that class. So of that class. This is what I actually said here, that area is directly proportional to the frequency. This area represents the frequency of this graph, of this x value, right? So that is always continuous because we only draw the histogram we only draw histogram for continuous variables, group data, right? So that is what we do. So that denotes that area of this bar is actually equal to the frequency. Fine. So suppose you're understanding this point over here, guys. So let's say, for example, there's a question and the question asks me that how many students, let's say that the question asks me that how many students are there between x value 36 till 45. So let's suppose there's a question which says how many students are there between x, or how many values are there between 36 and 45. So that, let's suppose that's what the question asked me. The question asked me how many values, what's the frequency of 36 till 45. So if you want to find out the frequency for 36 till 45, that means you should be trying to find the area of this. So this is 35, that means this is 36. And you want to try till 45, that means you'll be finding the area of this. So you will be finding the area of this figure right here, right? So this is what you will be trying to find. Fine. So suppose you're understanding this point over here, guys. If let's suppose if we have to find the frequency of 36 till 45, which means we will need the area between 36 and 45. So if we want to find the area between 36 and 45, we know that this distance is actually equal to 4, because this is 35, this is 36, this is 40, so this distance is 4, and the length is actually equal to we already know the length is equal to 13.2 over here, right? So it's, oh, sorry, 13.6. So the area is going to be equal to length times breadth, or length times width, plus the area of this rectangle over here, which is going to be 5. So this is 5 times this length over here, which is actually going to be equal to 3.2. So our area is going to be 13.6 times 4, plus 5 into 3.2, which if I calculate that, that will actually give me 70.4, right? So roughly around 71 elements are there between 36 to 45, right? So the 71 elements are there between 36 and 45. So just one thing that you have to understand is that the area between the graph, area in the bars will actually give you the frequency. So area will actually give you the frequency. Now let's go ahead and do this question. So this question says that this histogram represents the time taken for children to solve a puzzle. And this A represents 78 children, right? So we have this is the time taken and this is the frequency density, right? So the question says that what is the area that represents one child? So what is the area that represents 78 children? So 78 children are actually represented by this area here. So 78 children are represented by this area, which is equal to 2. So this is 2 times 27.3. So which is equal to 2 times 27.3, which is equal to 54.6, right? So 54.6 square units. So area is always in square units, right? So if 78 children are represented by 54.6 square units, we have to find how much does one child represent? How much area does one child represent? So one child is actually going to take how much area? So let's suppose what we're going to do is, since there is a direct relationship between that, there's a direct relationship, that means their division is actually going to be a constant. If 78 children take 54.6 area, then one children will, let's suppose, take x amount of area. So x is actually going to be equal to, so I'm going to cross multiply here, x is going to be equal to 54.6 divided by 78, which is actually equal to approximately 0.7 square units. So that actually tells me that what area represents one child. Now the question is asking me what is the total number of children. So total number of children would be the total area of this all the graphs, right? So that will actually give me the total number of children, because it will give me the total frequency, isn't it? Right? So here I have the total area. So the total area under the histogram is 210 square units. So if total area is 210 square units and each child takes 0.7 square units, that means the total number of children is actually going to be equal to total area times the area taken by each child. So the number of children divided by the area, right? So that means this is going to be equal to 210. I'm sorry, this is not going to be like that. This is going to be reciprocal of this. So it's going to be 210 divided by 0.7, which is going to be equal to 300 children. So I'm going to repeat again. What is the total number of children in this school? So the total area under the histogram is 210 square units, and each child takes 0.7 square units. So the total number of children is going to be the total area divided by the area per child. So which is actually equal to total area into child over area. So you can see that area and area get cancelled out, and I get the total number of children, right? So that means it's going to be 210 divided by 0.7, which is equal to 300 children. So suppose you're understanding my point over here, guys. This is the introduction to the histograms. I suppose you're understanding what I'm trying to explain here. Let me just go ahead and summarize this. So histogram is used for data representation, and that is only for grouped data, right? So this is actually only for grouped data. And you find another variable, which is frequency density, which is equal to, so the value of frequency density is equal to the frequency over the class width, and class width is nothing but the difference between the upper class limit minus the lower class limit, right? So that is what class width is. Another thing is that this is how the frequency table looks like, the histogram looks like. This is the frequency density, these are the x values, and this is how your histogram is, right? And since you know that f is equal to the frequency density into the width, that means this is the width and this is the frequency density, The area denotes the frequency. So area is something which will give you the frequency, right? And based on which you'll have a lot of questions. Fine. So I suppose you're understanding my point over here, guys. So thank you very much for watching this video. Don't forget to explore our website, perfect-course.com. Explore, like us on our Facebook page, and follow us on Twitter. And don't forget to give us your valuable feedback on our email address. So thank you very much for watching, guys. I'll see you in the next one.